So EDC, Energy Development Corp. So we'll talk about the 5 C's in their digitalization strategy. An overview first with EDC. So they're one of the largest geothermal operations in the world. They have 4 sites with about 25 operating turbine units, over 40 years of operations in the Philippines. So EDC is part of the First Gen Corporation. First Gen Corporation has a fleet that accounts to it's now about 20% of the Philippine capacity, and they have committed to have a clean and renewable energy portfolio. They always have said no to thermal. Just to show you how geothermal works, I'll show you a short video.
Imagine clean energy that can keep businesses going. Hospitals open. Airports running. Geothermal energy generated by the Energy Development Corporation. Using the Earth's natural heat, it can power us 24/7, day and night, rain or shine. Geo energy powering infinite possibilities.
So also the next video will show Manny, Portugal, discussing the high-level PI journey that he has done so far. So without further ado, I'll give you a short video.
Hi, I'm Manny Portugal. I'm Head of Technology and Digital Transformation at the Energy Development Corporation. The Energy Development Corporation is the operator of the world's largest wet steam field, where we contribute roughly about 10% of the country's electricity requirements coming from geothermal or renewable energy. Our journey really started in late 2017 when, upon visiting the different sites, there was a crying need for real-time information coming from our facilities. And that time, people really kept data to themselves in silos. Every department had its own set of information, which they would use to justify their decisions, which may sometimes contradict information coming from different sources. And getting that information was something difficult for a lot of people to get. And it would be a pain to get that information, to collect the information, put it in one location, trend the information, and relate it to other pieces of information across the enterprise. So when we looked at the PI server, it was a great platform for time series data. And we found a platform where we can quickly collect the information, share the information, visualize the information, analyze the information, and basically get this information into the hands of the engineers and get it into the hands of other people who may have a different view or need using this information to help generate more electricity, help improve operational excellence in running our steam fields. Today, we've established what we call the Integrated Performance and Reliability Center, where really it's a center of excellence where we have subject matter experts collaborating and analyzing the information and providing advice to the field and trying to understand what's going on with the different assets in our power plant. Turbines, generators, even transformers, and especially what's happening in the steam field. And the ability to get all this information correlated and share it across the field has proven invaluable to operations. Today, we are able to actually unearth or surface a lot of operational issues which would have otherwise been very difficult to do had we stuck to a manual way of collecting information. And by being able to get the engineers to work together, we're able to increase collaboration, we're able to decide much faster, and we're able to get things and do things in a more objective way. Where are we headed? We are looking at more and more uses of the data. We are uncovering new things that would have been difficult to do. We are synthesizing information. We are using analytics. We've hired a data scientist to help our engineers understand the data and develop models and patterns of how our wells, for example, and how our equipment is behaving. We have a very dynamic environment because we extract gas from natural wells, which can behave differently on a day-to-day basis. And that's the value of being able to have this information in real time. We're now incorporating maps into our analysis. We are incorporating meteorological stations. We are monitoring emissions as well and relating it to production. We are incorporating our rain gauges in the weather because our fields are located in typhoon-prone and landslide-prone locations. So weather is very important to us. So we're also collecting information, putting it on the PI server, and incorporating maps so that we can determine where landslide-prone areas are and undertake the necessary action. We see a lot of uses for the PI server, and I'm happy to say we're just scratching the surface, and we see more applications. With the implementation that we've done, the system has actually paid for itself, more than double of what we've done. And we continue to see value in it as we exploit it more and more.
So, before I discuss the operational challenges, I'd like to give you a briefing on the background of Mr. Portugal. So Mr. Portugal has been in the IT industry for a long time, has been an IBM executive in his previous career, became a country manager of VMware. So my point is, when he went to EDC in the middle of 2017, he's really an IT guy. He's not an OT guy. He doesn't know plant operations. But what he did, we went to each of the plants, talked to the operations, talked to the plant managers, immersed himself in the plant operations on how we could help. We did a lot of workshops with the OT guys, telling them, what do you need? How can we help you? And that changed the culture within EDC. We also adapted agile methodology. Each of the plants are recommended to provide resources for the agile teams. So because, as you can see, one of the more glaring one is the 90% PMS, or preventive maintenance. So when they do their PMS, everything is shut down from the power plant, steam field, and the wells. So it's kind of tricky, even though the fuel itself is free. It's the natural gas coming from Mother Earth, but it is acidic. It has a lot of small particles that they have to clean up. So when the power plant has low megawatt output, they really don't know where the problem is. Is it in the wells? Is it in the steam fields? So they shut down everything. And most of the plants have their own P&L. They don't talk to each other. So the data is very siloed. So when Manny came in on late 2017 or middle 2017, he got the teams together and made a strategy, which they call now 5C. We connect what we can connect, collect it, put it into the PI server, compute, meaning we built a center of excellence built on subject matter experts that they have already, put it in AF. More importantly, communicate. Always communicate, build PI vision displays, send emails, send notifications, and now they're doing correlation and advanced analytics. So because before, all the divisions, drilling, the well, the reservoir management, the steam field, power plant, really don't talk to each other. Now they have this collaborative, again, center of excellence team. When there's a low power output from the power plant, before they, in a way, think about, do we drill another well? Is it because of the well collapse? Is the steam field, what's wrong with the steam field? Now they know end-to-end what's happening into their operations. So working with their consultant, Boston Consulting, again, we provided, they created a team on each of the categories. An agile team for operations, an agile team for the technology part, and the agile team for management, so that each category has their own, they have their own skin in the game. So that's what they're doing, because If it's just operations without management support, it will not fly. So they created, from the agile teams, they created mini applications. So they created operational KPIs based on operations, asset monitoring, critical asset scores or KPIs. These are the applications on top that they are building, and how they are building it. This is the timeline which we're actually in a way advanced because we built up the early warning system already. But what they did is start with one site, for example, BGBU. Then once we create the template, it goes to one plant to another, and the central PI becomes like an R&D. That's where the central or center of excellence comes in. Sample the displays that one of first we created. This one was very valuable for them because their first time to see that there's a pattern that the well collapses every month for 7 days. So they cannot, because it's again nature, they cannot prevent the collapse of the well. But what they saw is that there's a pattern every month that it collapses. Now the team is very integrated in the way they solve the problem. They collaborate because they know it's a pattern already. A few days before, they huddle up. They know what's happening, so that before the time to restore is 72 hours. Now it takes them only about less than 24 hours to restore the well, because every day that the well is not like online, it's a lot of money for them. So they do now, they do stand-up huddles. They call stand-up huddles because they go to the center of to the operation center. They don't do reports or Excel. When they meet, they go to the screen, only standing up, so that it's direct to the point discussions, because they don't want to finish the discussion in 10 to 15 minutes. Solve the problem, what's the problem, then go out. Do actionable items. They don't want to sit around for 30 minutes to 1 hour. So they do a lot of stand-up huddles, especially if there's a notification, then they go directly to the screens. Of course, they still have data link reports just for audit purposes and for reporting. What we did for them as an early warning system, because when they talk to several vendors providing them predictive or any other AI or machine learning, they felt that each of my turbines are unique. It cannot be the same algorithm. So what we built on is, towards the left, is their trip logic. They gave us manuals, the diagrams on how trip logic per asset is doing. Then we converted it into an AF. Then we created displays. So in the displays, most of the time, the other applications monitor this one, the end calculation. But what we're doing is monitoring all the tags. So it's a simple early warning, like for example, this is a notification. It says that 2 out of 3 has reached its limits. And there's already a interpretation, which we're working with them via AF. So we built the AF, put in all the algorithms, then their own subject matter experts provides the interpretation or diagnostics. So we work with them, again, via the Agile. We do every 2-week sprints, monthly sprints, so to reach a certain level of maturity into the system. So they built a stoplight monitoring for the fleet. These are the ones that they're monitoring right now. These are the sites. However, they're starting to use Exergy analysis model. They put it into AF as well, because as I understand it, the Exergy model calculates what's coming in and what's coming out so that they know if there are really losses in all the processes. So AF has become a very valuable tool for them. And once we put it in one of the sites, it goes to the other sites already as a template. So it's much more convenient for them, especially on flexibility, and they are now using it across the fleet. So they're integrating it with S3, as you saw in the video. More and more data is coming into S3, especially on the weather stations, the rainfall, because most of the plants are actually on the side of the mountain. If there's an earthquake, sometimes part of the power plant actually goes down the mountain. So it's very critical for them to see rainfall, the soil, the corrosion, everything, because it affects the power plant. In terms of architecture, so there's 2 PI servers on HA per site. Then there's a collective one on the HQ. This one serves as like the center of excellence and also development. But to secure it, because the IT has certain standards, we put in unidirectional gateways from Waterfall. So it's via OPC going to PI, then the PI data goes into the HQ server. Then we push it to the ArcGIS Geo Event server. So it would be a continuous and evolving architecture, but for now, that's it. We may add more unidirectional gateways because this is just part of the DCS. Since we're connecting a lot of wireless sensors in the steam fields, we are figuring it out where best to put in so that all the data is protected. When we say 5 Cs earlier, connect, we don't want any excuse for the data to come in. So even if we cannot connect it automatically, we built manual logs. Before we tried the manual logger, but the operators doesn't want to use it because they're not used to it. Again, we didn't want any excuse, so they're using Google Sheets. So we put in like an add-in on Google Sheets, so that every time they submit for approval, it goes to PI. So no excuses for not getting the data. Another thing that we built is an SMS or email event annotation, because there's always something that needs to be put in as a note. For example, a trip came in, but technically it's not a problem, but they need to put in because of maybe of weather. Because we need to put that note in so that the analysis is complete. They're trying to decrease the bad data. So with this one, there's no excuse again for the operator, for the field worker to send that data or note back to the PI server. Then we use PI event frames actually to collate everything. Some early wins, like I mentioned, so 15 from 72 hours now to 15. So again, the visibility of data is very important to them because they're now trading the whole fleet into the spot market. So the real-time data is very important to them. They want to understand where the next outage is because if they're bidding into the spot market, they know how to bid low or high. There's still manual logging, but now they're getting the data. So what's next is integration to their CMMS. We're now they're now testing a PI integrator for business analytics. They're now installing steam field devices on the pipeline. We're getting it via Heart IP. This one is very interesting because it's about insurance. If they could prove to the insurance company that they're monitoring everything, it may lower the premium because they're on a hazardous area. If they say that we're monitoring all the rainfall, landslide, and we have safety notifications, the premium would go low. So it's not just about operational efficiency, but also on the safety side and insurance. So that's it, basically, in summary. So before, root cause analysis takes some time as well. But now, since we have the early warning system in the core assets, we know actually which tag we need to check. And the engineers know how to quickly do actionable items. Correlation, collaboration has become very important because they're now talking to each other. From the OT, IT, even purchasing are involved on how to enhance the process because they're seeing, again, the data. They have visibility. And the results, or meaning the step forward, is really do predictive. But now they're just checking on how to make the early warning more efficient on all the components and assets that they have. So that's it. So if you need to contact, please do let us know, or for any other questions. Thank you.
Thank you, David.
Thank you.
Awesome. So getting the heat out of the core of the earth, huh? It's pretty impressive. Any questions for David?
Questions?
Right up here, dear.
Come on with the mic.
My name is Bill Grant. I'm with DTE Energy. So you mentioned that you're trying to bring in data wirelessly.
Yes.
And that you've been trying to decide on the best methodology to do so.
Yes.
What methodologies have you considered thus far, and which architectures do you prefer?
So right now they're building up via WiMAX. WiMAX is the communications that they chose. So they're putting Emerson sensors. So we get it via hard IP, wireless. So the WiMAX, because the problem with the plants and the steam fields is on the side of the mountain. There's no cellular data. They tried LoRa, but they cannot go through some of the mountains because you're going to several mountains. So the best way that they think is WiMAX. Some would maybe argue because it's older technology, but for them, they see it seem fit for their use because of their mountainous territory. So it's via WiMAX. Thank you.
Other questions?
Don't be shy. All right. I want to thank you.
Thank you.
Dave,
Thank you.
Thank you so much.
Thank you. Thank you. Thank you.
Fantastic.